Hi everyone, here's the video for the part that was missing from yesterday's class. So we're going to talk about symmetries in the polar coordinate system. Now, why are symmetries useful is, for example, we looked at the two cases in rectangular coordinate where you can have symmetries about the y and x axis, which means that figuring out what the graph looks like on one side is enough to figure out what the graph looks like on the other half or other quarter. So the same idea holds for polar axis. The first one is, for polar coordinate, the first one is about the polar axis. So basically it says that if replacing theta by negative theta makes no change in the equation, then there is this kind of symmetry. It means that if you have the point r comma theta, then you also have the point r comma negative theta. Okay. Now that's because, remember, if you have a negative theta, then that's just a clockwise rotation as opposed to counterclockwise. The second one is if replacing r by negative r and theta by theta plus pi, right? So it means there's a symmetry about 180 degree and there is no change. It means that if you take this this point r theta, then the one that's diagonally opposite it, negative r theta, is going to be the same. That's because this is exactly theta plus pi. Right? This is 180 degrees. And lastly is about theta equals pi over 2, which is the vertical axis here. And it says if you replace theta by pi minus theta and there is no change, then for every point r theta, there is going to be the point r pi minus theta. So if this is theta, pi minus theta would be this angle, right? Or maybe it's easier to look at it this way, saying if this is theta, then this is theta, then this angle is pi minus theta. So it's kind of like the symmetry along the y-axis, meaning whatever you see on this half gets reflected on the other half here. When the most common one that we use is the first one, which is replacing theta by negative theta. So let's look at an example how that can be done. Sketch this using symmetry. First of all, observe if I replace theta by negative theta, this becomes 1 plus 2 cosine negative theta, which is back to being cosine theta, and that's because in quadrant 1 and quadrant 4 cosine is positive, so that takes the same value. Okay, so we follow the procedure that we had before. Is first we plot this in rectangular coordinates. So 1 plus 2 cosine theta is going to have a max value of 3 and a min value of negative 1, and it's going to look like that, where the turning point is pi and this is 2 pi. Now this symmetry means that to plot the actual function, all I have to really look at is going to be the top half. Right? So this symmetry guarantees that I only have to look at the top half. So I only have to look between 0 and pi. Okay, so at 0, what do I get? At 0, this is 3. Right? So at 0, I have 1, 2, 3. I start here. And then at pi, it is negative 1. Okay, so let's do the 0 case first. So at some point it becomes 0, What is that point? You can find that point by setting this equal to 0. So 1 plus 2 cosine theta equals 0 happens when cosine theta is negative half, or theta is cosine inverse of negative half, which comes out to 2 pi over 3, which is what? Which is 120 degrees. So somewhere here, r becomes 0. So it crosses this point and ends up at being r equals negative 1 at pi. Now pi, or right before pi, is quadrant 2. So the negative of that would be quadrant 4, right? So it ends up at negative 1. So you go around and you end up at 0. And now from symmetry, we know that what happens in the bottom half is just going to be a reflection of this. So the bottom half would look like that. So it's kind of like the cardioid, but it's a cardioid with a loop on the top. So these are obviously, these are not functions because they don't pass the test for a function, but these are interesting curves that, that we study. So you can also plot this without having to use symmetry, right? You can just go ahead and do the same argument for pi to 2 pi and use that to plot. However, just some of the simple symmetries like theta, negative theta is helpful because then you can just make 2 copies and combine them. That's pretty much all that I wanted to talk about.